Hey there, Sherwood. What's up? I got a request to do problem 13 on page 66 and to make a video about that. So here goes. We're looking at lesson 2.1 on limits, and we're supposed to find the limit of this expression as x approaches negative 2. And the instructions in this problem set say to determine the limit by substitution. So apparently we're supposed to just plug in negative 2. We're also supposed to support our answer graphically, so we'll look at that part as well. Okay, so here it goes. We're going to replace x with negative 2, and then when we compute, we get negative 2 minus 6, which is negative 8. And so we need to know, what is negative 8 to the power of 2/3. Well, one of the rules of exponents that we know is this one right here. In situations like this one, we know that we can multiply the exponents. 2 times a third is indeed 2/3, so we can do that. In fact, that's not what I wanted to do. Whoops, let me do that in reverse. 1/3 times 2. Okay, the same principle applies. A third times 2 is 2/3, so this is a legit move. And so now if we know what negative 8 to the 1/3 is, then we can figure out the answer and square it. Well, something to the power of a third is really the cube root of that thing. So we're looking for the cube root of negative 8 squared. And the cube root is just a number which, when multiplied by itself 3 times, gives a result of negative 8. So if we just puzzle over that for a little while, we can figure out eventually that the answer is negative 2. Negative 2 times negative 2 is positive 4, and 4 times negative 2 is indeed negative 8. So the cube root of negative 8 is negative 2. And we are meant to square that result. So negative 2 squared is positive 4. So it appears that the limit of this expression as x approaches negative 2 is 4. Let's pop over here to our Desmos.com calculator, and let's actually type in that expression that I just evaluated, just for the sake of verifying that negative 8 to the power of a third, which is a cube root, I said was negative 2. It is. And if you raise negative 8 to the power of 2/3, so the answer is 4, and it is. Okay, furthermore, if we graph the function x minus 6 to the power of 2/3, the graph should support that. So let's go ahead and take a look at that. X minus 6 to the power of 2/3 has this graph right here. We want to look at what the outputs do when the inputs are really close to negative 2. And we're hoping to see an answer of 4. So let's see that. Slide this around, boom. Okie doke, so we're zooming in around negative 2, okay, and we're going to slide. That input is approaching negative 2, and the outputs should approach 4, and indeed they do. So that's it. We used substitution to figure out the limit. We used some rules of exponents along the way. If a calculator is allowed, you could have just gotten that answer right from there. If you want to understand kind of the analysis behind what the calculator is doing, you could use these things, and I'll leave you with this question. In order to make this argument work, you really do need to know something about negative 8 to the power of a third. And I mentioned the fact that that really is a cube root, and so my question is, why is something to the power of 1/3 equal to a cube root? Something to puzzle about. Actually kind of a fun question. Thanks for listening, thanks for watching, hope you're enjoying your Labor Day weekend. I'm out.